Welcome to FYI, the 4-Year Innovation Podcast. This show offers an intellectual discussion on technologically enabled disruption, because investing in innovation starts with understanding it. To learn more, visit arc-invest.com.
ARC Invest is a registered investment advisor focused on investing in disruptive innovation. This podcast is for informational purposes only and should not be relied upon as a basis for investment decisions. It does not constitute, either explicitly or implicitly, any provision of services or products by ARC. All statements made regarding companies or securities are strictly beliefs and points of view held by ARC or podcast guests, and are not endorsements or recommendations by ARC to buy, sell, or hold any security. Clients of ARC Investment Management may maintain positions in the securities discussed in this podcast.
Hey everyone, welcome back to FYI, ARC's 4-Year Innovation Podcast. I'm joining you as your host, Tasha Keeney from ARC. I'm joined by my colleague, Pierce, and today we're interviewing Noah from Built Robotics. Noah, thanks for joining us.
Thanks, Tasha. Excited to be here.
Great. We're happy to have you. So I think we'll start just by quickly introducing your company to our listeners. What do you do? Kind of what stage of the company life cycle are you at today?
Sure. So I started Built Robotics in 2016. And the initial hypothesis was autonomy is coming. Self-driving cars are going to be a thing, but it's going to take a little longer than people expect. And it's probably going to become commercialized in more constrained environments first. And I really decided to focus on construction because it was an area I kind of knew. I'd grown up around construction. My dad worked in construction when I was a kid, and I worked for him in summers during high school. And I just knew there was a ton of labor out there that needed to get done on job sites, and there weren't the people to do it. So that was kind of the initial hypothesis. I think that's largely been borne out, actually. If you look at sort of the evolution of the self-driving car industry here, and we've deployed now on a few dozen construction projects around the U.S. and actually around the world, in Australia as well. And what we've really sort of zeroed in on, particularly in the last couple of years, is renewables and utility scale solar. So that's our big focus now as a company, is basically developing autonomous construction solutions for solar.
Great. Yeah. And, that certainly fits in with the work that we do here at ARC. We care a lot about autonomy, and we've done a lot of work on the autonomous taxi space. And, our top line conclusion there is that ultimately, by taking the human out of the loop, you can make the machines have higher utilization rates, but you can also, of course, lower costs, and that productivity gain that you get as a result of those two dynamics can be pretty dramatic. So you all build it's like a hardware system and a software system that you can retrofit onto existing machines, right? And then how does that get sold into customers? Because I know the construction industry has its own sort of unique dynamics here.
No, you're very astute to point that out. And the answer is we kind of are flexible. And, like a lot of enterprise businesses, we sort of, we adapt our go-to-market to fit the needs of our customer. So there's probably sort of two basic models, and there's kind of, a spectrum in between. The first is we just rent out what we call the exosystem. So that's that upgrade kit that you install on an off-the-shelf Caterpillar or John Deere or Komatsu piece of construction equipment. And we rent that out. And then we also charge that's the hardware fee. And we also charge a software usage fee. And then those sort of two things combine together and create like a RaaS model, a robot as a service model. That works really well for some customers. And then the other end of the spectrum is closer to almost being like a turnkey sort of service provider, where we are training their folks, pretty involved, and then maybe even getting paid on a piece rate, effectively, or progress rate. And that can work well. We've done more of that in Australia. And then we think that there's probably going to be a spectrum where, as over time, we think more folks are going to gravitate toward that RaaS model. But we think that, every construction company is kind of at its own place in that journey. And, we're happy to meet customers where they are and, just do whatever needs to be done in order to get the work done.
So what sort of like features made your systems particularly well suited to solar and renewables, as you were mentioning earlier?
Yeah, so we have kind of our initial product that we've launched and deployed on a bunch of different projects is an autonomous trenching solution. So what is a trench? It's basically a long, skinny hole in the ground. And you use trenches for buried infrastructure. So, pipes for water, wastewater, for pipelines, for gas or oil and water, and then also for buried cable for telecom and for power. And it's really the buried cable for power that's kind of as merged as the use case, the end use case that's just, the best fit for our technology. So you can imagine kind of where we are and the kind of work we're doing. Utility scale solar farms are just these massive, massive projects. So, the biggest project we've been on was probably 20 miles by 10 miles, something like that. You can get lost out there kind of in the desert and, there's just nothing to see. And these cables need to route sort of all over that project. And they're generally buried because of a few reasons. It's kind of interesting to get into it. So the first is it's safer. The second is you actually improve the longevity of the project because you don't have the cable you can't access the cable. And then the third one's really interesting is you actually can keep the cables cooler when they're underground. And the temperature of the cable really matters because as that cable's temperature goes up, the resistivity of the copper goes up. So you actually end up losing more of your power. So you want to have your cables buried where they're cool, safe, and then obviously where they're safe for people who are maintaining the solar farm. So on that one project, there were over 100 miles of trench that needed to be installed. So just, many, if you were one person digging that trench, you would have been there for years. And so we kind of have developed a system where we have these excavators, which look like standard excavators, but they have the exosystem that's sort of installed on the back. And they're tracking all over this job site and digging trenches and basically following the blueprints that they're given. So that was kind of our initial product. We've gotten really good traction. And the new product that we're developing is really based on customer feedback. And what we heard from everybody was, hey, the autonomous trenching is great. The productivity is actually about where a human operator is now. The quality is good. The reliability is where it needs to be. But digging a trench is actually a pretty small slice of the pie in terms of the overall cost and complexity of building a solar farm. And what we decided was we wanted to basically take on a bigger chunk of that work. And the scope that we identified that we think is the best fit for our technology is what's called pile driving. So you imagine that solar farm again, and you have cables underground, in the trenches, and then above ground you have what are called trackers. The solar technology, which really kind of become the dominant design in the US, is what's called single axis trackers. So you have these rows of solar panels. The rows are always oriented north-south. And what that enables is that you can rotate the solar panels so they face east in the morning, and then throughout the day they rotate and face west. So you have these, hundreds of thousands of solar panels that are all kind of arrayed on these trackers. And the trackers are themselves installed on piles. And a pile is an I-beam, basically, that's been driven into the ground. And again, on this one particular solar farm, I think there are 300,000 piles that needed to get installed. So it's incredibly repetitive work. And it's very time consuming. It's also super loud. If you're on a piling crew, you have to wear double hearing protection. So in-ear and then over-ear hearing protection because there's a real risk of hearing loss. And so we kind of identified that as and that can be up to 10 to 20% of the cost of building a solar farm. So we identified this as a really good place to focus, and we'll be launching that this summer.
So you've got pile drivers, excavators, you've got trenchers, and then with this most recent acquisition of Rowan, I assume concrete laying equipment as well. Are there any other construction equipment categories that you can claim to work in?
Yeah, in the past, we actually automated loaders as well, like skid steer loaders and CTLs. And then we've done a bunch of work with dozers doing finished grading. And I think we've gotten to the point now where our technology is compatible with a wide variety of OEMs and types of equipment. And really the thing that I think determines, scaling and success for us is less about the technology barriers and more about how do we make something that's easy and efficient for the customer. And, that's where I think the pile driving is really going to stand out for our customers.
And you mentioned that, the core solution that you started with, you're matching productivity of a human, but, I imagine that in doing that, you're reducing the labor demand on the job site. I guess, yeah, what is that as we think of like, the cost savings, like productivity enhancements that you all bring? How should we think of that equation, like maybe, by technology or broadly now that you're sort of handling different areas of tasks here?
Maybe I can use California as a specific example. We're based in San Francisco. We've done a lot of work in California. Everybody's heard the cost of living is very high in California, and wages are very high as well. So if you're a skilled equipment operator, the negotiated union rate for you, including wages and fringe benefits and everything else, is I believe at $93 an hour, something like that. It varies a little bit between NorCal and SoCal. And then good operators in the labor shortage kind of environment that we're in, good operators are actually even paid over scale, so above that. And then that's not including overtime. So to kind of turn that into a cost per year, a good operator can cost over $200,000 a year. And then on top of that, you generally have an operator who's paired with a spotter. So you have an operator who's running the equipment and a spotter who's kind of working around the operator and giving them hand signals to let them know when they're going too deep or if they're about to hit anything. And you have this team. So the cost of running sort of a production excavator on a large solar farm can be close to $300,000 or $400,000 a year in California from a labor standpoint. So there's a significant economic incentive for our customers to try to bring some technology to bear here. The other piece, though, which I always highlight, is that you just can't find the operators. The average age of an equipment operator is almost 50 years old now, and it tends to be trending up over time. So you just don't have the folks who are joining the industry. And, digging a trench is important. There's a ton of trench that has to go into a solar farm, but it's not the most sort of, high touch skilled type of equipment operating. So generally, if you need to do, you want to have your skilled human operators on those tricky bits where you maybe, you need to do some rework and you're digging around cables or, you're in among the arrays, that type of work is the more complex work where you'd like to allocate your human labor. So that gives you maybe a little bit of a sense for the kind of numbers we're talking about here.
So as you mentioned, spotters, like kind of brings up a thought we were having earlier, which is like when you're digging in all these dynamic environments, different soil textures and compositions, and like you have to worry about obstacles underground and things like that. Like I imagine you have a significant sensor suite you have to retrofit each of these with. And so like, could you tell us a little more about those sensors and how it looks, what it looks like to install them, and also what kinds they are?
So we have, I would say, a pretty similar sensor suite compared with a lot of the self-driving car projects out there. The sort of core of it is, this liquid-cooled mil-spec computer. So it's a really rugged computer. It's installed in like tanks and helicopters and stuff. And we've got some pretty robust NVIDIA GPUs in there. Then we have cameras. We use a bunch of different monocular RGB cameras currently. We actually don't have LiDAR on the system. We did in the past, but we don't currently. We've run into a lot of issues with ruggedness in the construction environment relating to LiDAR. Then we have GPS, and we use RTK GPS. So it's basically an augmented GPS that takes your accuracy from a couple meters down to about a centimeter. So it's this really, really accurate GPS, which is really cool. And then we use IMUs, inertial measurement units, and we use those all over the system to basically measure angles and the acceleration of different parts of the machine. And that's kind of the core sensor suite.
Got it. And you said that, you don't think that technology is a barrier. So would you say that like the autonomy for what you need it to do is like pretty much a solved problem? And I guess like how much, it seems like as you deploy more and more of your solutions, you should be able to sort of learn from those deployments and you get all that great machine vision data. Yeah, what does that trajectory look like over time? Or is there one?
Solve problem, I think, is maybe a little bit of a stronger word. I think we've managed to solve it, but it's taken, a tremendous amount of effort over the last, 6.5 years here. And I also would say, too, that, I've gotten to the point now where given a new task, I feel like we can extend our platform, this hardware platform, software platform that we've developed in order to enable that task. But it takes some time, it can take, up to maybe a year of R&D kind of focused on basically extending our current technology to encompass that. So we're not really at the point quite yet where we can just sort of like make an API call to a robot and then it can, do some task that it's never been, used for before in the past. So, and I think we're going to kind of be in that place for a little while. And, that little while could be, years or even decades. But I think that what I was kind of trying to say before is that I think we're at the point now where the tech works, and the challenge is more about getting folks to embrace the tech and make it work for them and kind of within their organizations, within their sort of like standard means and methods. That's, I think, the big focus for us. So we're spending a lot of time on training. We have a partnership with the union, actually, the IUOE, it's the International Union of Operating Engineers. And we're developing some curriculum with them to actually train operators to learn how to become robot equipment operators, or RAOs. So that's a big focus. And then also just working with our customers to really identify, hey, this is a task that we're spending a ton of time on, or maybe we're having some issues with safety or rework. And, our customers would like to basically explore autonomy for those particular tasks. So I think that's kind of the stage that we're at now. You asked about like, where does this thing go? Where's the trajectory? I think that, if you, think back into previous decades or, previous sort of eras in construction, we've kind of been able to do almost everything that we can do today for a long time. The first skyscrapers going up in the late 1800s, early 1900s, right? And they're not fundamentally that different from the kinds of things that we can build today. What I think is different is, first of all, it's a lot safer. We have, construction still is a dangerous industry, but it's far less dangerous than it used to be. And the second thing is that we do use equipment, all over the place. So if you see a job site today, you see hydraulic equipment everywhere, and if it's not, and also battery operated equipment everywhere. So those are kind of your two main modalities for getting work done. Whereas in the past, maybe it was steam, or maybe it was even, mules or men who were just, hauling on ropes or whatever needed to get done, right? And so I think that all of those places that you see hydraulic equipment today, those are going to start to be, it'll still be hydraulic equipment, but rather than it being operated by a person, it'll be operated by a computer. And so I think that's what's going to kind of change. And that's how the construction industry is going to evolve over the next, 10, 20 years here.
Yeah. So speaking of safety, how exactly do you, we've heard about your 8-layer safety system that you guys integrate, kind of like working as like a stack of Swiss cheese, where some parts are kind of holy, but like if you line them all up on top of each other, you can't get through. Like, what kind of things are you looking for in your 8-layer safety system, and then how do you expect that the safety will be regulated for robots in the future?
Yeah, and I should yeah, we do reference the Swiss cheese model. I also should reference, or I should mention, for the audience that we didn't come up with the Swiss cheese model. That's actually a sort of standard model. I think it was originally maybe from aircraft safety. So it is it sounds a little silly, but it's actually a broadly accepted sort of way of thinking about safety, and essentially just having contingency plans and trying to have uncorrelated safety solutions, so that if one of them fails, then not everything does. And yeah, we have an 8-layer safety system. Let me see if I can recite them all. So we have, it starts off with basically a constrained environment. So, we put up a safety barrier around where the robot's working, and that tells people to sort of stay outside of where the robot's working. And frankly, that's the most important one. People are pretty smart, and the main thing is making sure they have the knowledge so that they can make smart decisions. The second thing is a geofence. So that's basically telling the robot, hey, stay inside the safety barrier. And, that's obviously important to separate the robots from the people. Then the third is signals that basically tell people who are working alongside the robot when it's actually in autonomous mode. So we have these blue lights that are on and they're solid all the time. If the computer system's on, basically the exosystem's on, and then they start to flash. And there's a fast beeping sound when the robot's actually operating autonomously. And that's kind of another, warning sign that like, hey, the robot's actually doing stuff right now. It's not just, sort of sitting there, and you should stay away. Then the fourth one here is we have cameras, that can detect people and basically decide, hey, somebody's coming up close to the robot, therefore it should stop. We also have basically a bunch of like health monitors for the robot. So it can tell if, maybe it's starting to tip over because it's on a very steep slope, or, maybe there's like an engine fault or hydraulic leak. And, it can tell all of those things and shut itself off and stop. And then we also have a system we call Guardian, where we actually have our own folks. We work with a third-party company, but we have our own sort of folks that we've trained who are constantly monitoring the robots all the time. And they're almost kind of like, folks who are monitoring like a closed circuit TV system. And they're providing another sort of set of eyes and ears. Then, let's see. The last piece, I think, is we have signs that you basically put up around. And again, it's all about just educating people and making sure they know that, hey, there's actually a robot here, an autonomous machine, and it's working by itself. That might have been all of them. I think so. And so the important thing here is that, again, it's knowledge. We need to make sure that folks understand that there is, a robot here. And, we will, every time we deploy a robot to a new job site, we actually do an announcement, to the whole, everybody on the site crew. Typically folks have like toolbox talks, or they maybe do like an all hands basically, on Mondays or something. So we think that's really important. And then the other piece is, basically making sure the robot doesn't overextend itself. We don't want it to go outside the geofence. We don't want it to keep on operating when there's any kind of a hardware issue with the system. And if you can kind of do those two things, then we think we can actually create a pretty safe system. And, very proud that we've operated for tens of thousands of hours now with zero robot-related safety incidents from our technology. And I think that one of the big things that's different about construction autonomy compared with self-driving cars is that we're operating, on private land, and we're operating in a place where you actually can put the robot basically, in a constrained zone right there, a work zone. And that makes it a lot easier for us to ship a system which is safe versus having, cars that are, driving on public roads with, varying conditions and people who, pedestrians who might jaywalk right in front of the car or whatever. So we think that's one of the big things that's enabled us to accelerate, commercialization here.
When you said a sort of constrained barrier around where the robot operates, and it sounds like it has a system in place and sensors to detect when someone's coming, but the idea is for people to sort of stay away while it's in the autonomous mode. So does that mean that theoretically the machines could operate a lot faster than they do today, or is that not how it works? I'm thinking of in factories, robots that are the non-collaborative kind that are sort of chained off tend to move incredibly quickly. And or does it not work the same way in a construction site?
We're generally maxing out the capabilities of the machine. We're opening up the hydraulic valves as far as they go and basically moving the machine as quickly as it can go. And the reason for that is that, the machines are kind of designed to be operated by humans. So it's actually a pretty interesting question. Hey, what if they don't need to be operated by humans? And, can they move more quickly, or can they, can some of the control systems actually start to change? I think the answer is yes. But we've decided to really stick with partnering with, the sort of biggest construction equipment OEMs, rather than trying to develop something ourselves, just because, we stand on the shoulders of giants here. This equipment's been sort of battle tested and proven on job sites around the world over decades now. So thinking ahead, will, some sort of dedicated autonomous equipment be created? I think absolutely. But I think, we want to take our time in order to get there.
So, you're pushing this REO exosystem paradigm where you've got one guy who's ostensibly operating possibly a fleet of different pieces of equipment. And so you could go and give a robot a task at one site and then drive over to a different site, give that one a task. How present does he need to be at every site to supervise? And also, I guess what we're ultimately trying to ask is, when can humans be completely taken out of the loop? Or is that even something that's on the radar for you guys?
So I guess to answer the last question, it's not even on the radar for us. And the reason for it is that there's just this work that needs to be done that's sort of peripheral to the core autonomy. And, it's things like fueling the machine. It's setting up that safety barrier. It's talking to other crews on the job site and making sure that they're ready for trench to go in the ground. So that kind of human collaboration we think is always going to be there. But yeah, you might have one REO who's operating a handful of machines and getting this incredible speed up, basically as a result, for the productivity and for his employer. Probably the way to think about it is maybe in a machine shop where you have a bunch of CNC machines, which are actually these highly automated, sort of robotic machines. But you still have one person who's generally tending, a handful of machines. And we think that kind of that mode of working with robots extends pretty well to construction as well.
So, I mean, like in CNC machining, sure, like when you set the thing off on its job, it can be, fairly set and forget. But I think that there's a lot of skill that goes into the design of the tool path and all of that. So in the same way, is there, like, how much skill is there involved in giving the equipment that the exosystem its tasks? Because I know you have your own software, and you've said it's quite intuitive, but I mean, is it pretty basic, or is it like a better operator for that software is going to get a significantly better result than somebody who's more new to it?
I think one of the things that's, I guess, is kind of interesting about, our work is that we don't have that much control over what gets done. That's sort of handed to us from the site engineers who are actually designing this overall. It's electrical engineers, civil engineers who are designing this overall solar farm. And it's essentially like it's almost like it's such a tight specification that there's not that much room for variation. Where I think the really skilled REOs shine, though, is about utilization. So how do you keep the machine running, and how do you think, one step ahead, two steps ahead, make sure that there's, construction, there's often conflicts where, you have maybe the electrical crew is trying to put in, buried cable, and then you have a mechanical crew that's actually trying to like stage a bunch of piles for install, right? These two crews can often kind of conflict, and you have to get a superintendent or a foreman out there and figure out who's kind of going to have precedence. So that type of like thinking ahead and making sure that there's no conflicts throughout the whole critical path that this robot's working on, that is, I think, where people really shine. And that then you just end up going from, maybe, 6 hours or something of productive digging. And if you're not doing a great job, where you can get, 8 or 9 or 10 hours of productive digging, if you are doing a really good job managing the robot and managing the other crews around the robot.
Yeah. So, I mean, you'd mentioned how much it costs to hire an operator in California, at least for, per year. But I mean, like, have you done any studies that look at the rate of equipment utilization relative to human, because humans need to take breaks, they need to do this or that. I mean, like if you're designing a path or a task for the robot, essentially, then like how much more efficiently can it accomplish the work, and how many fewer hours are you required to rent the equipment for, or use the equipment for, to get the same amount of work done? Have you done any like studies into that?
Yeah, I mean, typically you're going to have 2 15-minute breaks and a 30-minute break over the course of a crew if you're an operator. And then plus you're going to have times where you're not necessarily on break, but you're just kind of, you're not sure what to do, or you're waiting. And the robot just works through all of it. So, that's kind of a minimum like 10% speed up in a 10-hour shift. And when we've seen that, I think probably the longest uninterrupted streaks that we've had are close to 14 hours. And the way we've done that is we even let the robot run later than a human operator would. And that's, something that's viable because the REOs have other activities that they can do. They can, this is typically something we've done in Australia, where we have these, super, super distributed sites, and there's kind of like a work camp where people stay. And so we can even have the REO kind of based out of the work camp, and then they kind of only, drive out to the robot at the very end of the day when it's getting dark in order to turn it off. So yeah, we've gotten, really nice speed ups and efficiency gains there.
Yeah, theoretically, could you run this 24/7? I mean, I'm assuming, now it's coming in stages, and, as you said, there still needs to be a human in the loop for giving instructions. Of course, you have humans in the background monitoring, but could it be an all-night continuation?
Yeah, I mentioned there that the REO would drive out and turn it off at night. The reason for that is actually just because we don't want to bother the ranchers who, probably are never going to go there, but technically, like, this is their land and we want to, be respectful of them. But we have gotten permission on a few projects to do kind of like basically tests where we do like, 24 hours of operation or 36 hours of operation or whatever. And yeah, we've gotten basically like, in one 24-hour shift, we've done 3 times the work of a typical 10-hour shift. And the reason for that is you just don't have the same kind of stop-start, stuff to do every morning. So yeah, we've had really good results from a handful of 24-hour tests we've done, or overnight tests.
Okay. And, you've added these capabilities through Rowan, this new product that the piling system that you have coming out. Is your goal to sort of own autonomy within specific job sites? You partner with the machine makers. Like, could you imagine? It seems like your company would be pretty attractive as an acquisition target one day. Is that what you want? Sort of, what's the future that you want? What do you want Built's ultimate sort of mission to be?
I'd like to build an independent company that stands the test of time. And there's a couple companies that I think we look to. I mean, there's recent companies. I think SpaceX is, every nerd loves SpaceX, right? And we certainly look to them, and we admire that, they've stayed private. They're working on these incredibly difficult technical problems, and then they're building a real business at the same time. So I think that that's kind of the pattern that we'd like to follow. There's also a construction company that a lot of people don't know, but it's called Laterno. And they were kind of the caterpillar of like the mid 20th century. I want to say they probably had like 60-70% market share in the US in like the 1950s and 60s. And then they eventually, I think, got acquired by Joy Global, and then Komatsu, Japanese OEM, now owns them. The cool thing about them, though, is that their heritage was that they actually were a contractor, and they were deploying their own equipment on job sites. And they were just getting this incredible, basically, advantage. That was how they sort of like really proved that their tech worked, and sort of was able to like, they were basically the ones who were really able to get folks to understand that, hydraulic equipment was the way to do large scale earth moving. This was in like the early 20th century. That sort of like, that's always, I found that really inspiring. This idea of just like going out there, deploying the robots, and then like, making sure that they work and like learning from them. I would say we've tried to follow that ourselves. So, I'll go out to deployments, pretty often, every couple of weeks, usually. A lot of our engineering team does too. And I think that trajectory of basically like going out to the place that the robots are actually used, and, making sure you're not kind of locked in an ivory tower or locked in an R&D lab, that I find super inspiring. It's what we've always tried to follow. So yeah, I think that's, I think there's just so much to do. If you look at like construction, it's about, $1.5 trillion almost in the US as a sector. It's a huge number of, folks that are employed, just a huge amount of spend. If you look at everybody's share of wallet, their mortgage, their rent tends to be the highest. So I think there's this incredible amount of construction that needs to get done. And I think autonomy is going to be a really big lever for us as a society to get people better constructed, better built world infrastructure at a better price too.
Would you eventually want your system to be factory integrated, sort of purposefully built onto machines? Okay, yeah, because it seems like right now, you need to go after this aftermarket solution. I mean, that's even what we see the other construction operators that are working on pieces of autonomy doing themselves because of the way that product life cycle works. But eventually you think it could all be integrated.
Yeah. And you can tell them like, I like history and I like looking at like, patterns from sort of previous eras. Something that I compare our sort of trajectory to is actually steam ships, paddle wheel steamers. For a very long time, ships actually would have sails and then also steam engines and paddle wheels on them, right? That was kind of the standard way of making ships for, a period of decades. And it looks kind of silly. Like it looks super silly actually now. If you look at some of these photos, it's like, why did they need this? But it's because like sails were this trusted technology. The ships had already been designed. In many cases, they'd already been manufactured. Ships super expensive. It's not like you're going to go make a new one, right? You're going to retrofit it. Or you would make a new one. You'd want to have both capabilities. And so I think we're kind of in that same period now in autonomy and in construction equipment. So I think that you're going to have, for the next, 10 plus years, we're going to have, excavator that's got a cabinet and joysticks, and, you can put a guy in there and, that you can operate it sort of the old fashioned way. But then over time, we're going to get to the point where we have purpose-built, dedicated, autonomous construction equipment as well.
Yeah, that reminds me of it's like the transition from the horse to the automobile. There was some similar things going on. It's like you had a semi-automated machine, but it was still being pulled by a horse, and it did look silly. But I guess that's what happened in the interim.
Yeah, exactly.
Do you think that in terms of the components that you need for autonomy, is that always going to be off the shelf. I see some of the autonomous car companies going after, well, I guess some of the companies that are using LiDAR at least want to bring that in-house. I know you're not using that, so not relevant here, but like in terms of, like the sensors that you need, or perhaps the hardware that you're using for inference, would that always be just partnering with outside providers?
I think so. And I think it's, if you're Google Waymo, like maybe you have the budget where it starts to make sense for you to just like try to spin up your own like LiDAR division, basically. But arguably, I'm not even sure if it really makes sense for Waymo, but I think that it does not make sense for us, at our scale and, sort of with our financials. So, and I think that, a question that is always important to ask is like, why now? Like, what is the thing that's enabling, your startup, to be successful now? And it's an important question because if there's not a good why now, then like maybe it's not like a good startup idea, right? And I think that the answer for us is that there's just so many pieces of technology that didn't exist, 5 or 10 years ago that we're now counting on. And, it's the cameras, it's the algorithms, it's the GPUs, the CPUs, it's even the IMU sensors. All of these things are kind of, really the self-driving car industry, I think, is propelling a lot of it, but it's beyond that too. It's even just the continued improvement from cell phones and obviously all the research that's being done in ML. All of that I think is blending together to basically give us the point now where all the Lego pieces are kind of out there, and then we're really much more of like a systems engineering kind of company where we're taking them all, gluing them together, creating a good architecture, creating a good UI. And that's how we're adding value for the customer.
So like as you become more and more competent at doing this kind of systems engineering, do you expect that like, sister fields like agriculture or things like that will become more easily accessible to you? Or do you expect you kind of remain within construction? How do you see that looking?
I think yes is the short answer. A lot of the equipment is fundamentally similar and the tasks are not that different either. But I think that the economics are pretty different, particularly between agriculture and construction. And, there's this, I think, a McKinsey study that was done a couple of years ago that basically looked at the labor productivity in different sectors of the economy. And the number one improvement since World War II was actually agriculture. We have these giant tractors and combines. We have GMO crops. We have, improved irrigation system, all different kinds of things. And so the effect is that it just takes so little labor now to create food that very, very few people are employed. We were actually on a wind farm project for a few months, and the wind farm was situated, sort of within a corn farm in Kansas. And I was talking to some of the guys who worked there, and it was like a 500-acre farm that had 3 people who worked there. It's like there's so little labor that's required in order to do this work now. And if you look at construction's this kind of crazy, basically like it's the opposite, where instead of it being more efficient, compared to the World War II, it's actually less efficient now, where it takes more people to sort of create the same amount of, if you want to go build another like Empire State Building, it's going to take you more people and more time.
And would you say that's because of safety constrictions or restrictions, or why would you say that is exactly?
I think that that's part of it. I think that other regulations are part of it too, in terms of just, zoning and environmental and things like that. But I think that the biggest reason for it is that the cost of living has just continued to go up. And so you have to pay those wages in order to attract people into the industry. And the means and methods haven't really changed. It's kind of like what I was saying before, is that, the things that we can build haven't really changed that much. And, the biggest, I would say that probably the biggest innovations are like, battery operated, like handheld equipment and then hydraulic equipment. So you just haven't had the same sort of like improvements that you've seen in agriculture and manufacturing and other sectors. So, to answer your question, will we sort of look at some of these adjacent sectors? I think we will, and we have to some extent. But I think that there's this incredible pent-up need in construction, which I think sets it apart, really from every other sector out there.
And, in the passenger car space, when you like the data stream that you get off of collecting images and video really helps you solve all these corner cases, and it's this huge asset. And I imagine that it is for you as well. But it must be it's slightly different because you don't have those surprise factors that you talked about where you would with like an on-road system. Do you think that in your case, it's more like this, helps me, one, have like these proof points to help with the adoption of the technology, but maybe also expand into other tasks? Or is that, how do you think of that asset that you're building?
Yeah, I think that I would say it's tremendously useful for us, mainly in the sense that, it's not necessarily that we're like running all of this whole data set through some like machine learning, training process, but it's more that we just have hit all of these things and we've kind of like baked them into our system, all these different edge cases and challenges. So I think it's more of like a traditional way of valuing that asset where, if you've just done a bunch of trials and you've deployed it a bunch, you're going to have a better system versus the self-driving cars. But that said, we still have, I want to say a couple million different images that we've collected from a bunch of different job sites. And we do sort of feed them all through our machine learning models and, we back test on it. And so that's helpful too. But I think that because of construction being a more constrained environment, you don't have to worry quite as much about that. Or another way of saying is that, we can have a machine learning system that's basically tuned to like what's expected. And if anything deviates from that, then oh, wow, we got to stop, right? That's one of our triggers in our 8-layer safety system. Whereas in, self-driving cars and public roads, you can't be that conservative or you're going to have way too many false positives. So it's a different way of architecting it.
We are in this kind of golden age of AI and machine learning where we're seeing all these crazy advancements, Chat GPT, and it seems like some of that, it has to be somewhat pervasive and make its way into other fields. And what we're initially seeing now, you could imagine, you're getting some sort of voice input into, a machine that wasn't really possible before. And I've also seen that, Tesla's using transformers to basically predict where lanes are as the car is approaching before it sort of can actually see what's happening. So I'm just curious, what types of AI you're using today, and have any of those advances helped you as you've built the company?
So we really use machine learning for perception, for computer vision, basically. And yeah, we definitely are continuing to see advancements there. One of a lot of people are focused more on things like language models, especially with ChatGPT over the last couple of months. And I think there's a bit of a perception in academia anyway that computer vision is kind of a solved problem from a machine learning standpoint. That's not how I think about it. And the reason is it's just how many nines do you want, right? And it's fine if you maybe only want 90% accuracy, then yeah, sure, computer vision is a solved problem. But 90% is not good enough in an actual commercial application where safety's on the line, right? You need 5 nines or 6 nines or something. That's what we're really focused on, is really how do we refine our machine learning model in order to get us that many nines, and do it without introducing these false positives. So I would say that we're not necessarily using maybe ChatGPT is not a part of our system, at least not yet. But I do think that we've been continuing to benefit from advancements in the sort of machine learning field, and yeah, it's absolutely one of the things that enables this technology to work today. Maybe one last thing on my mind, I don't know if we have time, but worth exploring a little bit about why we're focused so much on solar today. And I think the transition to solar is something that we need as a society. And the other thing though that I think is really cool is the IRA, the Inflation Reduction Act that was passed last summer. I think it's meaningfully shaped the construction industry, and a lot of different EPCs, these sort of large engineering, procurement, and construction companies, have sort of refocused their business around solar because of the IRA. And so we've seen that too. And a lot of I think in 2022, something like 15 or 16 gigawatts of utility scale solar was installed in the US. People are now projecting that by 2030, it's going to be 120 gigawatts or something. So we're going to see almost an order of magnitude increase. And a lot of that is actually due to the IRA. So, I tend to probably be more on the side of we don't necessarily want a ton of government intervention in a lot of industries. But I think that the IRA is actually, to me, it's just a fantastic move. I think that the fact that we are finally focusing and we have the budget to actually spend on transitioning to renewable energy, I think is pretty cool. And so it's meaningfully changed our strategy as a company.
So that's why, you think in your next generation product, you're focused on this area. It's becoming more important for that reason.
Yeah, exactly. And I think that, when you're making decisions at the board level, like you're looking a lot at like TAM, like your total addressable market, and the fact that the solar industry is growing so fast and, will continue to grow so fast is basically lets us sort of make a financially responsible, dedicated bet to solar, which is what we're doing now.
Great. And what's next? I mean, as we, we have a few minutes left here as we're wrapping up. What are you most excited about? What should we, as students of innovation, be looking out for you all?
So I think that, with our autonomous trenching solution and then our autonomous piling solution, that'll let us actually take a, big chunk of solar and, put it into our system, and, our robots can actually help in a big way, build a utility scale solar farm. But I think there's actually even more for us to do too. So, we're starting to think a little bit about material management on the site and, moving material around. It's a big challenge because you have, just like 18-wheelers all day long that are coming in and delivering parts and components. And then it needs to all get sort of distributed across this massive site. So that's a focus for us. And then actually handling the modules themselves, so the solar panels themselves, and getting those in position to be installed on the trackers. So that's another big focus for us too. So yeah, I think really, I also should say too, I think that solar is an exciting place for us because it's growing so fast, and the IRA and everything that's powering that. But it's a sector of the industry which is new. I was talking to somebody recently who worked on the largest solar farm in the US a few years ago. It was like a 5 megawatt solar farm. And to give you some sense, like the biggest solar farm in the US now is over a gigawatt. So 200 times that. And it's only in like a decade. So it's this sector that's developing so quickly that I think people are really excited and open to embracing automation too. So yeah, basically doubling down on solar and, looking at all the different ways we can help.
And I guess because of its newness, does it give autonomy kind of more of a chance because you're reconsidering the job? It's a new job site?
Yes, absolutely. And there's less, I would say that the people are definitely kind of, hey, this is how we've built solar farms for the last 5 years. So we don't want to change that much. But it's a lot easier saying, hey, this is how we've done it for the last 5 years than this is how we built, apartment buildings for the last 50 years, right? So the people the ruts are not as deep, I would say, in terms of how people like to operate. And solar is also, if you go to a solar farm, it almost looks like a fractal, right? It's like this sort of system that's, very simple and then just stamped out, a million times, over many, many acres. And that also, I would say, is conducive to autonomy because, robots are great at repetitive work.
That makes sense. Well, Noah, thank you so much for enlightening us today. We learned so much about Built Robotics and all the exciting things you're working on. We're excited to see new product. And thanks for sharing it with us today. Sounds like there's a lot of exciting developments happening in the solar space. So definitely something for our listeners to watch and look for. Well, I'd like to thank you for coming on the ARK Invest podcast. And I hope we continue the conversation in the future. This has been great.
Thank you, Tasha. Yeah, thanks, Pierce. Appreciate you guys making that time.
ARK believes that the information presented is accurate and was obtained from sources that ARK believes to be reliable. However, ARK does not guarantee the accuracy or completeness of any information, and such information may be subject to change without notice from ARK. Historical results are not indications of future results. Certain of the statements contained in this podcast may be statements of future expectations and other forward-looking statements that are based on ARK's current views and assumptions and involve known and unknown risks and uncertainties that could cause actual results, performance, or events to differ materially from those expressed or implied in such statements.